Hey, what is up, y'all? Happy day. This is the first time I've actually had to record a lesson in a couple weeks, since Miss Smith has been gone. So yeah, last lesson, I had y'all basically just a pre to whatever we were doing today and tomorrow. Um, I had you draw what you thought an ancient prehistoric turkey would look like. We just went over what extinction was and what evolution was. So we kind of know that. Based off the knowledge that we got from Miss Smith when she was covering the lessons, that kind of all species are kind of connected and that they have changed over time. So, reason why we did this on last Tuesday is because obviously Thanksgiving, and we got some time to kill before the end of the year. And you know what? I'm just gonna do some easy stuff. So yeah, because honestly, after this, we only have like 2 lessons left and like 3 weeks, and I'm not about to, yeah. So today we're gonna watch a little short documentary on the ancient Turkey ancestors. Following that, for work time, you are gonna read a National Geographic article on the American turkey's modern day cousin, in Mexico, and seeing how they're similar, different, and how they came to be. Okay, you are gonna have a worksheet to go along with it. It's just 9 questions, easy peasy, lemon squeezy. Okay, so first we're gonna watch this documentary. It's a short 7-minute one. If you hear munching, I'm eating deep fried Oreos because I was in the mood for something pretty good. A little ASMR for you. So yeah, this is from nature, obviously. But came back from when I was in high school. I was about to graduate high school. So yeah, watch just a little nature video, Crouching Turkey, Hidden Dragon. Yeah. Sit back, enjoy.
Birds are really weird in so many ways. They have such a short, stubby tail, I mean, even shorter than in a mammal. They have this really crouched, kind of zigzag legged posture. Of course, they can fly. Their body form is bizarre compared to almost anything else living. So I really like the question of, well, how did they get to be that way?
For me, it's a question of bipedality. I'm interested in things walking on 2 legs, which, I mean, in the modern world is basically limited to us and birds. When humans walk around, we tend to walk around on fairly straight legs. Our legs act somewhat like a column. So they support our weight using mainly the bones. It's a fairly straight line from our center of mass, the average position of our body weight, straight down the leg. Whereas when birds stand, they have very bent legs, these very zigzag legs, which mechanically is slightly counterintuitive because it takes a lot more muscular effort to stand like that.
All right, time to see the birds. Check out the posture of the leg is really interesting, that the knee is there, and then we go down to the ankle, and of course the toes. So it's a very crouched posture with especially the hip and the knee very bent. The thigh almost horizontal like this. So I got a posture like that.
The question we were interested in is, how did birds get like this? And we decided to look at the ancestors of birds to try and get an answer to this question. So we decided to look at dinosaurs.
One of the best fossil records of any vertebrate group is the dinosaur lineage, and that shows how birds got the way they are today. We just need to put it together in a computer and track the evolution of fossils we know, and that allows us to reconstruct how body form and therefore posture evolved.
So once you have your digitized dinosaur skeleton, this is a tyrannosaur here, you can then start what we call shrink wrap it. So start to place simple geometry around the body, which we do by just fitting these very simple hoop-like shapes around it. And from this, we can expand it into a volumetric model. And from this, it's relatively simple to calculate what we call the mass properties, that is the weight and the position of the center of mass of this entire complex shape.
So in our models, we chose animals that were represented by good skeletons, that were three-dimensionally preserved pretty well, and that represented the key changes in the anatomy of dinosaurs, from big, heavy-tailed, two-legged dinosaurs like T-Rex to later kind of short-tailed or more rod-like tailed, larger four-limbed animals like Archaeopteryx and Velociraptor. Oh, so cold. The crocodile really nicely represents the body form that dinosaurs ultimately evolved from. The common ancestor of crocodiles, birds, and extinct dinosaurs was rather like a crocodile in many ways in its general shape. So we look at the crocodile, huge muscular tail here. It's very much like what dinosaurs started off with early in their evolution. And short little forelimbs, slightly larger, more muscular hind limbs, nice big head full of teeth. Very different kind of body form than a bird, like this frozen pheasant we have here, or like the turkeys that we have around our lab, or the emus. We thought, just like everyone else, that as dinosaur tails shortened and became lighter, the center of mass moved forward, and that was the conventional story. Well, our computer modeling that Vivian and others did showed that the center of mass of dinosaurs did move forwards toward the head during their evolution, but it wasn't really the tail that drove that change of center of mass during their evolution, was it, Viv?
Well, no, according to our results, there's a stronger association between the development of large forearms, I mean, the things that eventually become the wings of birds, and that it was this trend towards larger arms that was driving the center of mass forwards more than the tail.
And that change of center of mass forwards would have required the animals to stand in a more and more crouched posture. So going from a straight-legged kind of posture, like in humans almost, to a more crouched posture, which birds have today.
More and more bird-like. The obvious question when dealing with anything about the evolution of locomotion in birds is this associated with flight? And our results suggest that, in a way, yes. If you have these very large forearms for flying, then because of the effect on the position of the center of mass, this will inevitably change how your hind limbs work, so what your hind limb posture is. But this is something that starts a lot earlier than flight. So a lot of non-flying dinosaurs, particularly the bird-like dinosaurs like Velociraptor and its relatives, had very long arms, which were presumably for something like prey manipulation or something like this. And this is this development of long arms that kind of kick-started the shift towards crouch posture, which was then inherited by flying animals and became sort of emphasized as the forearms got even larger to work as wings.
So I think that's really interesting, that there's a link between the way the hind legs work, the way the animal stands and moves, but also mechanically through the physics of movement, the changes of the center mass would have influenced the way the animals flew and ultimately allowed, perhaps, flight to evolve.
All right. So you just watch a little documentary on turkey ancestors, basically. So now what you're gonna do is for your homework or whatever work time, you're going to read this article. It's a National Geographic article. It might say you can't read or whatever, but what you're gonna do is you're gonna sign in. It does it to mine. It's not this one, but you should be able to do it that way too. Let me double check. No, you don't need to subscribe. If it does, you should be able to just hit subscribe now and just put your school email in. Okay. Let's see if it does it. A little video along with it. Guess it won't. But if it does ask you to input an email, you're going to put in your school email, okay? Yeah. So you're going to read that, watch the video. You're going to look about the male ocellated turkey, or not the male, but the ocellated turkeys, the Mexican cousin of the turkey. Look at that. Look at those ocellated turkeys. You're also going to be doing this little worksheet. It's 9 questions, 5 on the previous documentary video, and 4 on the National Geographic article. So if you need to go back and watch this is totally fine. There's no Ed puzzle. I'm not going to do Ed puzzle this week. I'm just not feeling putting that extra work in, to be completely honest. Next week we will, when we finish the lessons. So the first question is, in what ways have turkeys changed over the years? So you're going to look at the prehistoric kind of one that they went over in the documentary video and talk about how they've changed over the years. You're also going to answer the question, why do you think the person in the video is correct on their assumption of what the prehistoric turkey or the ancestor would have looked like? So you're going to talk about that one scientist, genealogist, and talk about why you think he is correct and what they would have looked like. You're also going to answer the question, in what ways were the current turkey and its current ancestors similar? Vice versa, the current turkey and the ancestor different. And when I mean current turkey, I mean the one that we're used to, the one with Thanksgiving, the American turkey. If you're looking up turkey, make sure you put animal, not the country, because there is a country. Because when I was typing in ancient Turkey, a lot of it came up was the country. Then you're also going to think back onto the art you made in the previous lesson. So last Tuesday, the day before Thanksgiving break, what you thought it would have looked like. Do you think you were correct? Why or why not? You don't have to be fully correct. You can be like partially correct. That's totally fine. Then you got 4 questions on the National Geographic article. How and why and how do you think the ocellated turkeys got to be the way they were, or the way they are? How are the ocellated turkeys and the American turkeys similar? Vice versa, how are they different? And what was your initial response to saying what the ocellated turkey looked like? Okay, this is all on Google Classroom. Let me move my big head. It's me. I win. I'm kidding. I don't even know what I'm talking about. Well, ASMR for you. Oh my gosh, week 16. Oh my god, so long. Oops, you're gonna have an assessment this week. So yeah, it'll be in here. Get the turkey worksheet, get the thing. The video will be under here. So you're gonna watch the video on the documentary, read the article, blah 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 blah. This is what I was talking about. You might need to sign in for the National Geographic, and if you do, just put the school ID at rcs.k12.il.us, and it will allow you to read it. It had me do it, and then I'm not gonna get emails or anything. Yep. So you're comparing, seeing how they're similar, different, and how they came to be. Okay. If you have any questions, please reach out. Easy day, easy peasy, lemon squeezy. Okay, cool. Bye.